Okay, so this is for Math 3, Unit 9, Objective 1, which is our volumes. And we're not just going to be doing volumes of our three-dimensional figures, but also doing truncated. And so there are some formulas that we need to know. So on your worksheet, there will be these given formulas. And so these are formulas that we do have to memorize. So we're not going to be given a formula sheet for the test, so we will have to take the time to try to memorize a few of these. Okay, so on your worksheet from Objective 0 and then again on Objective 1, we will be given formulas, but we do have to take the time to memorize them. Okay? All right, so in general, for our volumes, we have three different styles that we need to know. We have what's called a prism, and we have a pyramid, and then we also have a sphere. Okay, so we're going to start with the sphere here just to kind of make sure we're okay with that. So if we're given a sphere, which is like a basketball or a ball, so I'm going to draw in. Okay, so just drew a circle and then an oval shape inside of here to kind of give it that three-dimensional look. And so with our volume formula for a sphere, all we have to know is our radius. So just a reminder, our radius goes from the center to the edge. So R is our radius. And then that volume formula is 4/3 pi r cubed. Okay, so that is our volume formula. And so we're going to do two examples underneath that just to kind of make sure we get the idea. Okay, so let's say that we have a sphere. And the radius of that sphere is 2 inches. So in order to find that volume, I just need to replace the r in the equation with 2. So I know this is my volume formula here. So where I see an r, I'm going to replace it with 2 inches. So then my volume is 4/3 pi, and then instead of r, we're going to use 2 inches, and then raise that to the power of 3. So that would give me 4/3 pi, and then 2 to the third is 2 times 2 times 2, which is 8. And then the units are also raised to the third power. So instead of just inches, it now becomes cubic inches or inches to the third. Okay, so I can write it like that. And that just means I have a three-dimensional value, which all volumes would be three-dimensional. And then from here, I'm just going to put this over 1 and then multiply straight across. So I have 4 times 8, which is 32. So I'm ignoring the pi right now. It's going to go at the end. So then I have 32, and then 3 times 1 is 3. So then I have 32 over 3, and then pi, and then I could write it like inches cubed, or I could also write it cubic inches. Okay, so either way. So for my unit measurement, I could either have it as inches to the third power, so like that, or I could write it out as cubic inches, and that means the same thing. And so that would be my volume for a sphere. Okay. And let's do one more here. Okay, so this time I'm going to do the shape here. And I'm going to go all the way across like that. Okay. So what I have now drawn this time, so I have a half a sphere, right? So that's also called a hemisphere. When we are doing a half a sphere, that would be a hemisphere. Okay. So this time I gave you that the diameter was 10 meters. So the diameter is when we go from edge to edge, right, through the center, so the center being here. So from edge to edge, that's my diameter, and the diameter is 10 meters. So I know that the radius is half of the diameter, so if the diameter is 10, then the radius would be 5. So 10 divided by 2 is 5, and that gives me the radius. So 5 meters from the center to the edge, 5 meters from the center to the edge. And then from there I would use the same formula. So I would have, for the volume of the sphere, so the whole sphere, would be 4/3, and then pi times the radius, which is 5 meters, and then that's going to be cubed. And again, this would be for the whole sphere, right? So if this was a whole sphere, I would do 4/3 pi times 5 meters to the third. And so because it's not the whole sphere, then I need to multiply that by 1/2, or divide by 2, same concept. So this would be for the whole sphere, multiply by 1/2 gives me half a sphere. And then I'm going to work this out the same way. So I have 4/3 pi, and then 5 times 5 times 5, and then m to the third, and then times 1/2. Okay. And then put this over 1, because I'm going to try to squeeze this in here. So then I would do 4 times 125 times 1, so I'm multiplying straight across. So that would be 500 times 1, or 500, divided by 3 times 1 times 2, so divided by 6. And then I still have my pi, and I still have my meters cubed, or cubic meters. And then I can reduce that a little bit, right? I can divide 506 both by 2. So if I divide by 2, so half of 500 is 250, and then half of 6 is 3. So that's very tiny in there. And I want to leave it in terms of pi unless the directions tell me otherwise. Okay? So that's for a sphere. And then let's go to the prism. Okay. All right, so for the prism, I'm going to squeeze that in here. Okay, so that volume formula. So in general for a prism, so I'm going to also put cylinder in the same category as a prism, but I'm going to split it up in just a second here. So for a prism, in general, that would be our volume is the area of the base times the height. So I'm going to use a capital B when I'm talking about the area of the base, not a lowercase b, because that would imply just the base. And then times the height. So again, the capital B is area of base. So the expectation is for you to know some of your basic area formulas, but one of the ones that you may not know, and that would be your trapezoids. And so you had some of that on objective 0, but we're going to write this down just to make sure. So let me... Okay, so the area of a trapezoid would be the only thing that maybe you don't know from last year, and it wasn't on the formula sheet. But given a trapezoid, so if you were trying to find the area of a rectangle, you would just do base times height. But for your trapezoid, you have your height here, right? And so the height is the perpendicular distance between two parallel sides. So I have two parallel sides, and the height is the perpendicular distance between two parallel sides. And then, so normally we would just do base times height for a trapezoid, but it actually has two bases here of different lengths. So I'm going to call this base 1 and base 2. Okay, and it's not my bases because this is like my bottom, they're my bases because they run parallel to each other. So the area of a trapezoid formula is you have to average those values. So you want to find the mean between them. So you would add them up and divide by 2, and then multiply it by the perpendicular distance between them, which is also called the height. So that's the only area formula you may not know. The rest of them is I'm expecting you to know them, and if you don't, you can look on your Objective 0 worksheet and write down a few of them, okay? All right, so we are going to do just one example off of a prism, and then we'll do one for a cylinder. Okay. Okay, so I'm going to start by drawing a trapezoid. So it's not very straight, but pretend it's a nice equal trapezoid there, or isosceles trapezoid. And then I'm going to draw 2 lines off to the side here, like that, and go straight across. And then I'm going to draw one more down like that, and then like that. Okay, so then I know that this value here is 12 centimeters. And this one right here going across is going to be 8. And this will be 4. And then I'm going to make the height here 5. Okay. Okay, so this is considered a prism because the faces of them are all rectangle shapes. So if I look at this shape right here, that is a rectangle, right? And if I go to this one, it's also the shape of a rectangle. The ones I don't have drawn in but wrap around it are all rectangles. So that makes this a prism. And so because my faces are considered prisms, then I can find the volume using the area formula. So although it doesn't look like it, this is my base, okay? So the trapezoid is my base. So it's just a prism that's knocked over on its side. So if I want to find the volume, I know that it's the area of the base times the height, right? So the area of the base times the height. So in order to find the area of the base, I need to recognize this is my base, right? These are my faces. And so then the area of this is a trapezoid, so I'm going to be using this formula right here, right? So for a trapezoid, so I want to find the area of the base, I'm going to find B. In order to do that, I need to average the bases, so I know that if this is 4 centimeters, this has to be 4 centimeters, right? So if this is 4, that's 4. And then this is 8. So I'm going to take 4 plus 8 divided by 2. And then times the height of the base, so the height of the trapezoid, which is 5. Okay, so what I have done so far is all I've done is found the area of the trapezoid, right? That's all I have found. And so this right here is the area of the trapezoid. So I averaged the bases, right? 4 plus 8 divided by 2 times the height of the trapezoid, which is 5. I still have to multiply by this h here, which is not the height of the trapezoid, but the height of the whole figure. So the height of the whole figure is really 12 because it's knocked over on its side, right? So this is 12, so I want to just multiply by 12. Okay, and so I just realized I dropped my units here. So this is a centimeter here, centimeter, and then these are centimeters as well, so I'm going to squeeze that in. So 4 plus 8 is 12, divided by 2 is 6, so I have 6 centimeters, times 5 centimeters, times 12 centimeters. And so then I'm just going to do 6 times 5 is 30, times 12 is 360. And then I have 1, 2, 3 centimeters, so centimeters to the third. Okay. And then that's the volume of the trapezoid. Okay, so then the other object that I'm calling a prism is a cylinder. Okay. So the cylinder was on Objective 0 worksheet as well. So I'm just going to do just one example here. So example 2, find the volume. Okay, so it's really technically not a prism, even though its face is a rectangle, although it doesn't look like it. The volume formula is still the same, where you would find the area of the base times the height. So the area of the base times the height. So the area of the base, so that's just a circle. So that would be pi r squared, and r is 4 centimeters. And then times the height, which is 10 centimeters. Okay. So the formula is still area of the base times the height. So the area of the base is a circle. So I'm doing pi times the radius squared, and then times the height, which is 10 centimeters. So 4 times 4 is 16, and then that would be centimeters squared, and then times 10. So then 16 times 10 is 160. And I don't want the pi to come first. I always want it to go the number, then the pi, and then the units. So I'm going to multiply my number values first. So 16 times 10, and then my pi. And then I have 2 centimeters times 1 more, so centimeters squared times centimeters, so centimeters cubed. And then there's my volume. Okay? And again, leave it in terms of pi unless the directions tell you otherwise. Okay? All right, last one here. So for our last formula, so pyramid. So for a pyramid, it is the similar idea. So we have volume equals, but instead of just area of base times the height, it's 1/3 of that. So we would do 1/3 the area of the base times the height. And we're just going to do one example on this because we have to do the truncated as well. And so when we do the truncated pyramids and cones, we'll do some more just like that, just to get the idea. Okay? All right, so I'm going to draw, just going to do one example here. So I'm going to draw a triangle first. And then one off to the side here. So this is not going to be all that great because I'm not very good at drawing three-dimensional figures here. So we're just pretending this is a pyramid, like the Egyptian pyramids. So let me draw in some dotted to see if that makes it better or worse. So, okay, so there's the bottom is a square. It doesn't look like it, but I'm letting you know the bottom is a square. Okay. So we're going to say that this side right here is 8 inches. So this side would also be 8 inches. And then this side here, so that's perpendicular, is going to be 10 inches. And then I want to find the volume. Okay. So I know that the volume is 1/3 the area of the base times the height. So this base, although it doesn't look like it, I said it was a square. So in order to find the area of this base, I need to multiply these two sides, right? So I'm going to do 8 times 8. So 8 times itself, and then times the height. So the height is a little bit trickier, right? So this is not the height, right? This is what they would call, if you remember from last year, what they called the slant height. So in order for me to find the height, I need to look at this triangle right here, okay? So that triangle right there is a right triangle. And so if I look at that right triangle, the hypotenuse is 10. And then again, I know the drawing is not that great, but from here to here, this is in the center. So if this is 8 inches all the way across, this would be 4 inches, okay? So not the best drawing in the world, okay? So in order to find the height, so I'm going to call that h, I need to do Pythagorean theorem. So I know two sides and I'm missing, right, that third side. So I'm going to find the height, okay, and I'm going to just do that off to the side here. So it's a squared plus b squared equals c squared, but my a squared is h, so I have h squared plus, and then 4 squared equals the hypotenuse, which is 10 squared. And then from there, I'm just going to solve for that. So I know 10 squared is 100, and 4 squared is 16. And then to get h by itself, I'm going to subtract 16 from both sides. And then to get the square off of the h, I'm going to square root. And I can leave it as a square root of 84 in terms of a radical, or I can do decimals, but I know for 84, that's 4 goes into that, so that's 4 times 21, right? So 4 goes into 8 twice and into 4 once. So the square root of 4 is 2, and then I don't know the square root of 21, so that's kind of squished in there. So then the h I'm going to use is 2 root 21. Okay, so what I do is Pythagorean theorem, right? A squared plus b squared equals c squared. And then I did 4 squared plus h squared equals 10 squared, and then just solve for h. Okay, and then from here, I have 8 times 8, and then inches times inches, and then 2 square root of 21, and then inches. Okay. I'm going to put this over 1. So 1 times 64 times 2, so that would be 128, and then square root of 21, and then 3 times 1, and then inches squared times inches. And then my answer would be that. Okay? All right, so those are the three just kind of basic volumes. So we have prisms, which include cylinders, and then we have our pyramids and our spheres. Okay? So again, we have to know these formulas. And then our last thing that we have to do is our truncated. Okay, so one more concept here. Okay, so truncated. So truncated just means if like the top is chopped off. Okay, so we're going to do just one example here. So okay. All right, so for part A, the directions are find the volume, of the cone, okay? And then part B will be to find the volume of the truncated cone. So this is 8 inches over here as well. Okay, so what we're looking at here is we have that this is just a cone, and so we want to find its volume. So this is very much like our pyramid. So in order to find the volume of this itself, we're going to be using the formula 1/3 area of the base times the height. Okay, so find the volume of the cone. So 1/3 the area of the base times the height. So 1/3, and then the area of the base, so this is a circle. So area formula of a circle is pi r squared, and the radius is 8 inches. And so in order to do that, I would do 1/3 pi, 8 inches squared, and then times the height of the cone, which is 15. And then 8 times 8 is 64, and then inches times inches, so inches squared, and then times 15. So before I multiply this, I can see that 3 goes into 15, so I'm going to go ahead and reduce that. So 3 goes into 3 once, and into 15 5 times. And that's just to make it so I have smaller numbers to work with. So then this is just 64 times 5, and then followed by the pi, and then inches squared times inches, so inches cubed or cubic inches, okay? So the volume of the whole cone is 320 pi inches cubed, okay? So now in order to find the volume of the truncated cone, which is part B, so truncated again means just like the top was chopped off, okay? So I'm going to drop to the picture here real quick. Okay, so the truncated cone this is the top of the cone, right? So what I need to do is I need to find the volume of that. And so I know the volume of the whole thing, and then if I know the volume of the part I chopped off, I can subtract them to find the the volume of the bottom, right? So now I'm just looking to try to figure out what's the volume of this. Well, in order to find its volume, I need to use proportions, right? So that's what I need to do. And I'm looking at my example, and I realize I wrote this down wrong. So there should be a 10 here. So make that 7 into a 10, okay? All right, so in order to find that, I need to look at my ratios, right? So I want to figure out what is the radius of this part right here, okay? That's what I want to figure out. So I want to know what R is. Well, if I want to know R, I need to know what is this height right here, right? So the height of this right here. So I know the whole thing was originally 15, and now all I have is 10, right? So how much was cut off? So this height right here had to be 5 inches, right? Because originally the whole thing was 15, and now it's down to 10. So if the whole thing was 15 down to 10, that meant I cut off 5 inches, right? So 5 inches from the cone was cut off. So if I look at my ratios, okay, so I'm going to look at my scale factors or my ratios. I know that the height is 15 compared to 8, right? 15 compared to 8. So my ratio over here is 15 is to height, 15 is to 8. So the height to the radius, so 15 to 8. Okay, and then it should be similar, right? Similar triangles, similar areas. This is from last year. So 15 is to 8 as 5 is to R, right? So similar triangles. So the height of this triangle compared to the radius. So the height to the radius. So in this case, it's 5 is to R, right? So 5 is to R as 15 is to 8. And I know that they are similar, so that means they are equal. So the height to the radius, the height to the radius. And then I just need to solve. So my denominators are 8 and R. So I'm going to multiply both sides by 8 times R. Right? So some of you called that cross multiplying, but we don't want to do like a little trick thing. We're just basically multiplying to clear my denominators. So my common denominator is 8 and R, so I multiply both sides by my denominators 8 and R. So over here the R's cancel. 8 times 5 is 40. The 8's cancel. And then 15 times R is 15R. And then divide both sides by 15. And then I'm going to make that a decimal. So that would be 2.67. Okay. So I now know the radius of the tip of the cone. Okay. So I'm going to do the volume of just the tip. That's the part that was cut off. And so that volume is the same formula. So I'm looking up here. So it is 1/3 the area of the base. So the area of the base is a circle. So 1/3 pi R, right? Here's my R. Squared, so 1/3 pi R squared. And then times the height of the part that was cut off, which was 5 inches. Okay. And then I'm going to use my calculator for that. So that's 2.67. I times it by itself and got 7.11. And so now I'm going to do that, and then I'm going to do times 1/3, and then times 5. Okay, so there's the volume of the tip of the cone, okay? All right, so let's look at our picture again. So I know that the whole cone is this, and I know the tip of the cone is that. So if I want to find this part, the truncated part, then I just need to subtract these two, okay? So the volume of the truncated is equal to the volume of the whole cone, and then minus the volume of the tip. I just realized I forgot my pi. So since they both have pi in them, I just have to subtract the numbers, right? So I'm just going to do 320 minus 11.85. And there's the volume of the truncated. Okay, and then that's it.